Welcome back Year 12s to the next video, looking at Chapter 9. In this one, we're looking at amortization tables. So this is a way of, showing on a step-by-step basis what happens in a reducing balance loan. So just basically when we've got a loan that's being paid off over time, so you're making regular repayments until you pay it off, until the balance is zero, we call that an amortizing loan. So an amortization table is going to show you the payments, it's going to show you the interest as well, and then something called the principal reduction. So how much are you paying off the loan in each payment? Just in terms of the process, this really is a process that is applicable for our reducing balance loans, in that you start off with your balance that you owe, and then when your payment comes around, your compounding period comes around, you're going to be charged a percentage of that principal or a percentage of that balance. Now, after that happens, you then make your payment. Now, of course, with every payment that you make, some of that payment has to first pay off this interest that you were just charged over here. Only after you've paid back that interest will some of your loan be paid back, and that portion that's paid back is called that principal reduction. Now, however much comes off your principal, of course, will depend on how much interest you've paid, and the interest that you paid depends on how much you owe on the loan. So we're going to see these values change. We're going to see the principal decrease, we're going to see the interest decrease over time, and we're going to see the principal reduction increase, because the amount that you're going to be paying off the loan should start to grow as time progresses. After you make your payment, you're going to have a new balance for the loan, and then after that we repeat the process. So we go back to here, or back to the start, I should say, all the way back to here, and then we get to our next compounding period and we do the same thing. Add the interest, make the payment, part of the payment's going to interest, part of the payment's going to principal reduction, and we get our new balance again. We keep doing that process until the loan is repaid. Now, with some loans, we might only have, say, 10, 12, 15 payments. However, when we're talking about a mortgage, we're talking about potentially hundreds of payments, because you might be paying back your loan after something like 30 years. So these work for some really big loans, they also work for small ones, but what we're going to do is just look at piece by piece what happens with one of these tables. We'll start off with Sharon, who's taken out a loan of $5,500, so only a small loan, and she's charged 6% per annum on that loan. She's going to pay it back in quarterly payments of $504.24, and you'll see in the first one we're asked to find the quarterly interest rate on this loan. So it was 6% per annum. We're going to divide that by 4, so she's being charged 1.5% per quarter. In this case, I'm calling it R because this is the percentage that we're going to be using down here. Because when we are using or calculating interest, we obviously have to use the interest rate per compounding period. Okay, so we've got a table that's mostly incomplete, and we need to fill in the values. In this first part, you'll see I've put, a formula for how we get each of these. But I'll go through that slowly, and then you can use your calculator just to fill in the remaining values afterwards. So first of all, she's borrowed the $5,500. So you see at the beginning, payment 0, payment amount 0, she owes that $5,500. When it comes to the next payment, we need to do a percentage of the balance. Now the percentage is the percentage per quarter. We found that to be 1.5%. So she's going to be charged, when we come to this first quarterly payment, 1.5% of $5,500. So when we do that, we get $82.50. When we get to the next payment, note it won't be 1.5% of $5,500 anymore. It'll be 1.5% of what she owes it after this first payment. We'll get to that in a second. Principal reduction. How much is she actually going to pay off the loan? Well, she's going to give them $504.24. However, $82.50 of that has to go on interest. So the remaining portion, $421.74, that is what's going to be paid off the loan. We're going to use that now because she did owe $5,500, but she's paying back $421.74. So now she owes $5,078.26. Now, if we go to the next process, I won't write it out in full, but we're going to do 1.5% again, but this time of the new balance, so $5,078.26. When we do that, because it's a percentage of a smaller amount, we see that the interest has now gone down a little bit as well. When we do our payment, 524 minus that interest, 76.17, we're going to notice that the principal reduction has also gone up just a little bit. Because now, since she's paying less interest, more of her payment is going towards paying off the loan. Now we'll take away that principal reduction from what she was owing. So $5,078.26 minus $428.07, we get $4,650.19. And the process repeats. 1.5% of $4,650.19. We get $6,975. Do the same as we did before over here. You might like to do this all on your calculator and then just fast forward a little bit and check if you got the same as me. You'll see I am rounding off to 2 decimal places each time. That one comes out as a whole number, but this one will round off to 2. And here we have 56.62. So notice each time principal is coming down, principal reduction is going up. And finally, after the 5 payments, we get 3327.08. Now, if I continue that, I would get these values that are already entered. Notice interest coming down, principal reduction going up. And you'll see that at the end, all of payment 12 is empty at the moment. And the reason is that this last payment might be a little bit different to make sure that the loan is fully paid off. So what I might do is put 0 in our balance, because that's what we want after 12 payments. We want her to owe nothing. What I'll also do is put the principal reduction. I'll have it exactly what the balance was previously to this loan. So we want all of this to be paid off, the $496.78, and all of that has to happen in this last payment. So I'll fill that one in as well. You'll notice I'm working backwards a little bit here because now I want to know what interest was charged on this value here, the $496.78. So I'll do again 1.5% of $496.78, and you'll see I get $745. And finally, I can work out what would that final payment need to be. So I can add this principal reduction, in other words, the balance previous, to the interest that's going to be charged. And what you should find is it is 1 cent less than that other payment. Sometimes the difference is a little bit more. It might be a difference of a few dollars, but it is important with that last payment, if you are filling it in, that you work backwards. Since we want that to be 0, we know what the principal reduction needs to be. It needs to match the balance, and then we can work out from there our interest and our final payment. So that's what an amortization table looks like. Generally, you don't need to fill in this much of a table. Generally, you would have just bits missing like we've done at the start here, and you need to then obviously calculate what's missing and then sometimes interpret overall what's going on in the loan. And that's what I wanted to show you to finish off with. It's looking at the cost of repaying a loan altogether, but also the total interest that's been charged on a loan. And that's just from an amortization table. When we're talking about the cost of a loan, we're talking about how much have you actually contributed or how much have you paid back all together on that loan. So if we sum or add up the repayments, we'll be able to see how much in total. Just keep in mind your last payment might be a little bit different. The other thing that we can do once we do know the cost of a loan is we can see how much interest was charged altogether, because we can look at the difference between what a person has paid back and what they borrowed to begin with. And the difference there has to be equal to the interest that was charged. We're told here to use the amortization table from before to find the total cost for Sharon to repay her loan. So if you have a look at what she paid back, she paid 11 payments of $504.24, and then she had one payment that was just a cent less, so $504.23. So if we add all of that up, we should get $6,050.87. Now we want to know how much of this was interest. We know that she borrowed $5,500. And this is what she had to pay to the bank, $6,050.87. So this here is the interest that she must have paid. It's the extra she paid back on top of the original value that she borrowed. So $550, nearly $551. Finally, just an example on a smaller scale of an amortization table. We've got a $10,000 loan here, and you can see it at the start here, payment 0, balance is $10,000. We have a rate of 8%, however that is being paid back quarterly, it says it just here. So to get my rate per quarter, I'll do 8 divided by 4, and that gives me 2% per quarter. All right, it's being repaid in 4 quarterly payments of 26, 26, 23. Oh, that must be a little typo since it says here 20, so I might just fix that. The amortization table is shown. Okay, so there's a few things that are missing. So it says fill in the blanks in the table. To start off with, what I want is, at the beginning here, how much interest am I being charged? So to get this value, I need to do 2% of 10,000. So 2% of 10,000, if you do that, you should get 200. The next thing I can do is, well, it's going to take me down here, but if you have a look, I've got a principal reduction of 2426 and the payment was 2626. So notice there's a difference there of 200. That also tells me that the interest must have been $200. Over here, I've got principal reduction. So that will be our payment minus the interest. So if you do this payment here, 2626.20 minus my 151.48, you should get 2474.72. The boxes are a little bit small to write in, unfortunately. And finally, this one over here, the balance after the third payment. Well, I've got my balance from previous, $5,099.08. If I take away my principal reduction, I will be left with 2574.86. As you can see, all we're doing here is the same process as previous, but we only have to fill in a few gaps. Finally, we want interest total. So we just need to add these 4 figures up to get a total amount of interest, $504.96. In the next part, we're asked to verify that the total interest is equal to the cost of the loan minus the principal. So keep in mind that we had up here, total interest was $504.96. So since I know that, I'm basically showing that using this little formula here, I'm going to get $504.96. I want that to equal this. So let's check the cost of the loan. We've got 2626.20 multiplied by 3, because there are only 3 payments of that amount, and then we had 2626.36. So that was that final payment with the asterisks. So we get 10,504.96. So our total interest will be the amount we paid back, take away our initial value, which was 10,000, and you'll see we get exactly what we anticipated, 504.96, which was the sum of that interest column as expected. So if you do have all of the interest there and you can sum it up like we've done, you can get the interest. Alternatively, you can use this process here of finding the cost of the loan, the amount paid back, minus the principal, minus the amount that was borrowed initially. I'll stop there so that you can have a practice of this before we have a look at another way that we can model our reducing balance loans, or that we can calculate problems involving these loans, and that is by using the finance solver.